Hey everyone, welcome! We're about to jump into one of the most fundamental things light does. Reflection. I mean, it's happening all around us, all the time. But how does it really work? Let's dive in and find out. So, let's kick things off with a question you've probably wondered about. Why can you see your reflection perfectly in a mirror, but when you look at a piece of paper, you just see, well, paper? Both are reflecting light, so what's the big difference? The answer, you'll see, boils down to two beautifully simple rules.
All right, so first things first, what is reflection really? At its heart, it's nothing more than light bouncing off of a surface. That's it. Now, for the more, textbook definition, reflection is the bouncing back of light into the same medium, like the air around us, when it hits a surface. So the light isn't going through the surface, and it's not getting soaked up by it, it's just bouncing right back.
To really get this, we gotta meet the key players in the game. First, you've got the light ray coming in. We call that the incident ray. Then you've got the light ray that bounces off, that's the reflected ray. And then there's this super important imaginary line called the normal. It's drawn at a perfect 90-degree angle to the surface, right where the light hits, and it's the reference point for everything.
In that normal line, it is absolutely crucial for understanding our very first rule. It's all about equal angles, and believe me, light always plays fair.
And here it is, rule number one. The angle of incidence is always equal to the angle of reflection. In other words, the angle the light comes in at is a perfect match for the angle it leaves at, every single time.
We can boil this whole law down to just 3 letters. I equals R. That's it. I mean, how elegant is that? It's one of the simplest and most powerful rules in all of physics.
Just look back at our diagram. See how that angle I and angle R are perfect mirror images of each other? It's kind of like playing pool. You know how a ball bounces off the rail? The angle it hits at is the exact same angle it comes off at. Well, light plays by the exact same very precise rule.
Okay, so the angles are equal. Got it. But there's one more piece to this puzzle, and that brings us to rule number 2, the flat plane. This is what keeps the whole process nice and orderly. The second law states that the incident ray, the reflected ray, and the normal all lie in the same plane. So, what does that actually mean? Well, basically, the incoming light, the outgoing light, and that imaginary 90-degree line are all perfectly flat with each other. Let's go back to that diagram again. Imagine the whole thing is just drawn on a single, flat sheet of glass. The incoming ray, the normal, and the outgoing ray are all right there, on that surface. The reflected ray doesn't suddenly, pop out of the screen towards you or dive into the table. No, all 3 of them stay perfectly flat together on that same plane.
All right, we've got our 2 rules down, so now we can finally go back and answer that first question. What's the deal with the mirror versus the piece of paper? It all comes down to the surface.
It all comes down to 2 types of reflection. On one side, we have regular reflection. This happens on super smooth, polished surfaces, like a mirror. All the light rays that come in parallel bounce off and stay perfectly parallel. On the other side, we have diffuse reflection. This is what happens on rough surfaces, like paper. The light rays hit it and scatter in a million different directions.
And you can see it right here in action. With a smooth surface, organized light comes in and organized light goes out. That's what creates a clear image. But on a rough surface, something fascinating happens. Now, get this, each individual light ray is still perfectly obeying that I equals R rule. But on a microscopic level, the surface of that paper is like a mountain range. So one ray hits a tiny slope, another hits a little valley, and they all bounce off in totally different directions. The light gets scattered, and that's why you see brightness, but no clear image of your face.
And really, that's the whole shebang. So let's do a super quick recap just to make sure it all sticks.
So, what did we learn? First, reflection is just light bouncing off a surface. Easy enough. The 2 big laws are the angle in equals the angle out, I equals R, and second, all the key parts, the incident ray, reflected ray, and normal stay on the same flat plane. And that explains it all. Smooth surfaces give us that nice regular reflection for an image, while rough surfaces give us diffuse reflection, scattering the light.
Okay, I'll leave you with one final thought to chew on. Now that you know the rules, why are reflections so much clearer on a wet road at night than on a dry one? Think about it. The water is filling in all the tiny bumps and cracks in the asphalt, turning a rough, diffuse surface into a smooth, regular one. It's the laws of reflection, right there in the real world. Thanks for watching.